My name is Stefan Wintermeyer. That's my Twitter handle. And on the last slide should be my email address. Otherwise, Google will give you that. So today we are discussing caching for RAIDs. The slides, you wanted me to move or not? Not. OK, I have to stay here. Sorry for that. There are three parts of this talk. First one is why we care about that. Second one, how we do that. And the third one is how we can get to the last mile. We only discuss HTML, dynamic HTML today. So I'm not going to get into the whole asset pipeline thing, which is doing a good job by itself. You can optimize that too, but I'm not talking about graphics. I'm simply talking about how can I generate simple HTML pages fast. First part is, why do I care, or why should everybody care? There's an easy answer to that: save money. If you can deliver a web page in half the time, you probably can save half the amount of servers you already have. So you can make your decision, renting new servers on EC2, or taking a little bit time to optimize your code and to add caching to that. The second main reason is snappiness. You want to have a snappy and fast web application. That's absolutely key. Ilya Grigorik from Google was kind enough to give me a couple of his slides to get the idea of the whole snappiness thing. Google did a pretty cool experiment. They artificially slowed down their server for a specific user group. And you can see that starting with 100 milliseconds, which is nearly nothing, they already saw a result where people stopped using that service. And what might be even more interesting is, after they turned it off again, the users took up to 6 weeks to get to their old behavior. So a user of a web application has a specific behavior of how he uses that application. That's for any application. And they change that behavior depending on the speed of the application. Bing was even braver. They slowed down their service up to 2 seconds, which is very slow. And you see they saw drastic loss of users. So you really want to have fast web service. I upload the slides later. I'll publish the URL on my Twitter account. So this is just a graph here. If you are interested in that, you can look it up on the slides later. Interesting is this one here, which gives you an idea what is instant and what is fast. And we want to stay below 1,000 milliseconds. So that's the time a user has to wait the second or the moment he presses enter till the moment he sees the rendered web page. So we want to be within that rate. The problem is that many users today are already using just mobile phones or iPads or whatever, mobile devices. So even in the US, already 25% of all users are using such a mobile device as their only device to use the internet, to surf the web. There are countries like Egypt where it's even more extreme. So we have to take that into consideration when we talk about fast web applications. Because you see here and here, we just, after the whole network is finished, we just have like 400 milliseconds to generate our web application. And we actually have to reduce that number by about 100 or 150 milliseconds. The browser needs to render the page. So when the browser has the data, it has to render the page. So we end up at about 300 milliseconds, which we have to get our content rendered as an HTML page. So how do we do that? As an experiment, I used this Raspberry Pi, $35 US. I want to give that away. I have no idea how to do that. I will look for the Twitter subscribers which just made it in this talk, and will contact them by DM, the one whose name I find most amusing. So I'm using the Raspberry Pi to give you an idea how much you can get by good coding and good thinking. Hi, Carl. Because it's easy to buy quick, fast hardware. Everybody can do that. We use the following software stack. Use a Ruby on Rails 3.2. Obviously, you can do that the same with 4.0. It's a little bit easier, but there's no need to wait till 4. You can already do that with 2.3. I'm using Ruby 1.9.3, Nginx as a web server, Unicorn, MySQL, and the Debian Raspberry VZ as an operating system for the Raspberry. The example is a web shop. So this web shop has the following models. I guess everybody is able to understand this graph here. We have users, we have products. Products are in categories, and we have discount group. So any user in the right discount group gets a different price. We have a cart where a user can store his shopping. We have a rating system where a user can rate products. And we have line items. The UI is pretty simple. That's Twitter Bootstrap-based CSS. And you see the name of the products, the rating, the price. That's the anonymous view, so not a logged-in user. Obviously, we want to test with logged-in users too, so we have to have some sort of current user scenario. The current user just logs in. I have a demo account for bob@aol.com, and when Bob logs in, that's his page. And you can see Bob has a cart here where he can store the stuff he buys. And Bob has access to this detail view here, again with the cart, and he gets discounted prices here. That everything has to be calculated, obviously. And Bob gets a possibility to rate a product. Only logged-in users can do that. So, giving that as an example, how can we measure the success? I wrote a water script, which is an automation tool. That's part of this water script. This one here loops through these products and clicks on them and just walks through the whole thing. So to give you an idea, that's one loop. These were 3. So, but that's the basic concept there. That was non-logged-in user. When Bob logs in, he has to go through this part of the water script. He also looks around 3 different products, but he also rates these products. He buys some stuff, and he logs out. A total of 43 web pages. To give you an idea, I recorded that on my laptop. You're going to see how slow 30 seconds are. So here I start the water script. It fires up the browser and goes through all the processes. Now it's firing up the second browser for the user, so we don't have cache, an already filled cache for the browser. Okay. So that's it. How fast can we get this workflow running on a Raspberry Pi? So the Pi would be here, and I it's connected via network to the laptop. So I'm running the script on the laptop, but the server's on the Pi. That takes 116 seconds. That is our start. This part here gives you an idea where our problem is. It is nearly 3 seconds it needs for rendering this index page. And what is interesting too is, you see here, the SQL part, that doesn't take that long. So obviously, you always want to optimize your SQL database, no question asked. But it doesn't get you the whole way. Your problem is probably always the time it takes to render the view. So the first thing we're going to optimize is fragment caching. That's kind of the easy money. This part here is from the index view. That's the table. It's in Hammer. It's like EIB, just easier. And I added a simple Russian doll. So I have a fragment cache here, and I have a fragment cache here. And you see it caches the user and the product and the whole table for that user. That's the same just for the table to give you an idea what it caches. For RAIDs 3.2, you have to add these 2 lines to your gem file. Don't forget to run bundle install. For the production RB, you have to add this line. But now the question is seriously, how much difference can these 5 lines of code make? That's the difference. Same hardware. 5 lines of code. Didn't even take half an hour. So with these 5 lines of code, we can already cancel 50% of our EC2 instances. But it's all about the details. So you want to fragment cache each row, each table, each show content, each shopping cart, or the shopping cart itself, the navigation bar and the footer. And you just don't want to use plain Russian doll caching. Use clusters within the table. So this is our table here. Obviously, we have one cache for the whole table, but this is just 25 products. Let's say it's 100 products. If we would change one line, that would mean that the whole table has to be re-rendered. Of course, it's going to be faster than without caching, but why don't we use like little clusters where we say, okay, we cache 10 lines of the table in one piece of fragment cache, and then the next 10 lines again. What is very important here is, I don't know if you can see that, you want to be sure about your CSS. That's the zebra table from Twitter Bootstrap. You don't want to do a construct here where you say even or uneven, where you just alternate through the rows by yourself in the view. That's not going to get you far, because then you have to re-render everything. You want to solve that with a CSS. So about 2 hours of optimization there get me another 15 milliseconds. So that's just fragment caching. And that's not the end of the line. It's just, I want to give you an idea with how little work you can get these amounts of results. Please remember what DHA said yesterday about JavaScript and how you optimize the result there. So the example was a timestamp. Fragment caching, you really have to think about that. What is the optimal result? And what is very important, you need a clean database structure. You want to be able to touch through your has many directories. Because otherwise, if you don't touch, you can't use it. That's very important. Next step, HTTP caching. Web browsers and proxies don't want to fetch web pages twice. They use last modified and Etag to avoid that. To give you an idea about how last modified works, the web browser says, hello web server, how's live? My user wants to have a look at XYZ, HTML. I cached a copy last week. Is that still good? And the web server says, yeah, it is. You all know that. That's a 3 or 4 not modified. That means that we didn't have to render the view, which is the maximum of performance. To give you an idea of the Etag, which is the one we probably, or most people use, I made an example with curl on the command line. You see, I download twice the index page with curl, and I get different Etags, which is a checksum. If I set the Etag in the controller, which I can do for a user, and then here I say, give me the latest updated product. And both the current user and that latest updated product give me the Etag here. Then, when I download the page again, you see I get the same Etag here. Of course, I have to watch out here. I'm setting a cookie here, because that's all depending on cookies, and I'm using the same cookie here. But your normal web browser, like Chrome or whatever, does it automatically. So I'm just doing that here manually for curl. And that means that curl, or the web browser, gets the answer 3 or 4 not modified. That's the quickest response you can get. And again, the beauty of HTTP caching is that the view isn't rendered. You just look up in the database, what is the user, what is the last modified product, you generate your Etag, and then you can say, okay, yeah, the Etag the browser already gave me, that hasn't changed. So 3 or 4, maximum improvement. That gives us another 35 seconds. Obviously, these numbers here are depending on your actual use case. I don't know how many times your users go to your web page without having any changes on that. Only you know that. But right now we are up to 0.8 seconds per page on, again, 35 US. But you probably say that's not good enough. We waste a lot of time writing the initial cache, because obviously we cannot just read the cache, we have to write it once. Writing the cache normally happens the first time a user gets to your system. But we could preheat the cache. 99% of all web shops or service have peak times. And they have time in the night normally where they don't know what to do. Use that time to preheat your cache. Do it by brute force. Go through to the database and preheat any page which is important for you. That gives you another. I don't know what the difference now here is, but the result is 26 seconds. So that's fast. Again, don't be afraid of brute force. Brute force is your friend. And the server is bored anyway. So that was kind of the low-hanging fruit. The fastest page is delivered by your web server, by Nginx, without ever asking rates. And it's already happened. The whole public directory here, that's delivered by your web server. That's delivered by Nginx or Apache. That Rails is not even contacted for that. So Nginx knows in what directory your Rails application is. And first, before he starts Rails or before he asks Rails, he looks, okay, do I have a matching file for that request? And for example, for the 404, yes, I have that, so I'm delivering that file, and obviously that's the fastest way of doing that. So is there an easy way to save completed pages which are rendered by RAIDs? Yes, there is. You can use Caches page. You have to add that in your controller, and normally the standard is like for index and for show. That makes more sense. You could argue that you could do it for new. You couldn't do it for edit. That doesn't make any sense. gzip true says that it stores it automatically in gzip format. So Nginx doesn't have to do that. And again, brute force is your friend. Use that. The tricky part is, how do you delete out-of-date files? One way of doing it is by adding a hook here after update and after destroy, where you delete these files in the model. There are other ways, like using the tag of the model, where you have like it's a same idea like fragment caching, but on a hard drive. So you have to do the garbage collection by some sort of cron job yourself. Both is working. Do whatever makes more sense for you. With that, we are up to 19 seconds, so 6.1 times faster. But what about the current user? You don't want to. You just don't want to cache pages for anonymous users. You want to be fast for your logged-in users too. You can do that the same. You just have to think a little bit more. It's more coding. It's not done in 2 hours. Just to give you an idea about the numbers, let's assume we have a user base of 10 million. Is it million or is it billion? I'm always confusing. But million. Okay. Okay. I downloaded the talks page of Rails Conf, and that is, as a gzip file, 28K. So let's assume we want to cache that as a customized web page for over 10 million users. That would be 0.26 terabyte, which is not unfeasible. And it's getting even more feasible by not zipping it, but using a data deprecation file system. So then you get down to 5% of the total space you need. Obviously, Nginx has to gzip the files then, but that's pretty fast, and that's a trade-off which is worth to do. And again, you can become a very fast web service for that. Nginx will read the cookie, if you configure it like that, and goes to the directory which is valid for that cookie and looks for the files there. Again, that's not done in 2 hours. To set up a complex page cache system is a lot of work. You have to take not only Rails, but Nginx too. It does increase the snappiness of your application, but might not be worth the effort for small systems. So if you really have 10 million users, you might want to think about that. If you just have like 5 users a day, I don't know, go for a walk. Do we have any chance to get a single digit here? And yes, we have. But we have to think a little bit out of the box. You all saw the today's keynote from Yehuda. If we include, or if we add Ember.js on our stack of software, and here's the command line which you need to start a Rails application with all the Ember magic, then we have a one-digit number there. That's going to be 8 seconds. Again, same application, no change. But we are 14.5 times faster than our vanilla version, which didn't have any optimization. So the obvious question is now, what should you do in your specific case? If you have an existing Rails application, go for the low-hanging fruits. Implement fragment caching and HTTP caching. That is pretty fast to do. If you're heading for a new application, have a look at Ember. It's a pretty steep learning curve. I believe it's harder than to learn Rails, and that took me 2 years. Maybe we have to edit that part. Like, that took me 2 hours. But then don't forget HTTP caching. So if you use Ember, there's no need for fragment caching, but there is need for HTTP caching. So that's it about the caching. Thank you very much.